manually done, you have a lot of defines because the sockets, the syscall name under BSD, under Linux are not the same. I'm run mostly BSD. I attack mostly Linux systems. And yeah, I have to keep it really independent of my compilation platform. And yeah, all have to be made for the parasite to fit really with the target architecture. I will show you just after how it's written my parasite. And yeah, for sure, it integrates a syscall proxy server for later usage. So the parasite is, when you inject your shellcode, after you ptrace, you'll be able to ptrace init, you inject your mmap shellcode into init. The first time init, the mmap shellcode return, you have a signal alarm code, which is just launching for the first time the parasite. You loop in a non-blocking read during 5 seconds, expecting kind of magic ICMP packet to wake up the parasite. If it receives the packet, the parasite fork and connect back to the source of the ICMP packet and use as port the sequence number. That's really dynamic. I mean, you can use which port you want. It worked perfectly. And the parasite is waking up every 60 seconds with another signal alarm code. The strange thing we found with Dash, playing with that, is the parasite is multi-users. So you can have different guys using the same parasite because it's forking, and yeah, we was two playing. You're connected? Yeah, I am. But why I don't see you? I don't know. Oh, we are two on the box, two running the same parasite. Cool, nice. That was was funny. Just a little explanation why non-blocking read. Init is only the signal, the alarm signal. And when you have a read, you have the signal just before. The read is dropped, but after the read is relaunched, so it's blocking init. Yeah, I don't want to block init, else I'm fucked and the system go wrong. So that's why I use this kind of non-blocking read. The signal sent by init is air restart sys, something you normally don't have to see as user. Yeah. And yeah, that was a big pain to debug this, and finally I take my non-blocking stuff, and it was working, so I didn't care about the rest. So the little client I wrote is kind of tunnel between the parasite and itself to provide locally a syscall proxy access to your tools, all your tools you read. And if you just have to, yeah, you use your tool locally, you connect to your local syscall proxy, you will see it during the demo. That's it when you want to close. The client just sends an exit to the syscall proxy code in the parasite, and the parasite ends, and all stay in the same place. So that was the tricks. I really don't know if I was so fast. What hour is it? 6:30. In fucking, yeah, I have a fucking problem, I think, so no problem. I will drink beers. And somebody have a little joke to tell us, or no? So, okay, little demo. I think now I'm obliged to show you a bit of the code. So, as I told you, the parasite is, I have to define a lot of stuff locally. I have to execute all my syscalls like that, because I can't call the libc or else. Yeah, that's inline assembly. That's horrible, but there is no other way. I will just explain why after. So you have the syscall proxy in the parasite, and you have your normal C code. I'm obliged to play like that with the, because I can't use the structure, I can't call stuff in the libc or else, though that's really a pain to write. And so you can see at the end, parasite end, and at start, parasite start. And that's why I'm obliged to use inline assembly, because else, if I write another .s file, I can't pack it and make a big binary to inject into init. So that was my way. Maybe there is another way. I think that's already better than writing a full assembly parasite. Really more reliable. I'm at the moment playing with compression, steganographic cover channels and stuff like that. So the big problem with syscall proxying is packing your stack, sending the stack, resaving it, consume a lot of bandwidth. That's a lot of data, and you have to compress it in a better way. You have a lot of zero from the memory, so you can do it in a smarter way, but that was my way at the moment. So the library, what I did actually is those shellcode, those syscalls. So not really a lot, but that's already fine to write your tools. I will do the demo. I think it will be better to let you understand the stuff. So here I have a really evil bad server with a stupid vulnerability. I'm in. Ooh. I just launched my vulnerability, which is stupid. Fuck you, Linux. Just a basic buffer overflow, nothing more. It was just for the demonstration code. The exploit is written in this way. Oh, man. So you have your syscall proxy findsock edt patched shellcode. You have your basic stuff for exploiting the stuff. Oops. And here, stop the normal exploit stuff. And so you get ESP, you get IDT, you patch your kernel, you inject your parasite, and you repatch the kernel another time. So let's run this stupid vulnerability. Ooh, bad. Never do it at home, kids. That's an evil server. So it's running on port 5000, okay? Let's run. So I patch the kernel. I detect 3 types of different GCC, because you know this kind of, I don't know what is the name, Debian, that's it? The Debian guys are really weird. They like to patch their GCC, so I had to find new pattern in the kernel to patch the stuff I need. So I'm detecting different GCC version. I detected that the 2.4 kernel, and if I look if that's right, yeah, really bad. I will try it with 2.6.14 maybe. We'll see. So actually, I injected a 800 bytes long parasite into init, I have just a local little tool. Op. I will rename it in Oompa. The kernel is now patched to be able to see what init is doing in real life. Yeah, behind the behind the bit tracing stuff. So you have init right working normally. You can see it's not blocking. I have my client. You can put, yeah, okay, echo request or what you want. I wanted to connect back to port 9000, for example, and I send my magic ICMP packets. So I have to wait. You can see during this time, the parasite was making the non-blockant read and waiting for your magic packet. So we have to wait 1 minute. That's a good thing. So anybody have something to tell us or any question during this time? Nobody really? Yeah?
Okay, I'm wondering, so you're transferring the arguments from the syscall to the target?
Yep.
The return things back?
Yep.
So is this encrypted, or are you planning to I think otherwise one could write an IDS signature?
Actually, that's a work, because that's why I rewrite it totally, the parasite in C code, to implement this kind of stuff easily. And I'm more or less working on my main problem, which is the compression of the stream. But you can easily implement basic or more evolved encryption. And my way was more working with active steganographic cover channel with a fake web browser, which is making a lot of queries to have a stream and to steganography your usable stream into. That was my way, but because I was thinking, okay, if I have to implement kind of encryption routine, it will take a lot of place. So I don't know. Just XORing the stream is really not interesting. And I don't know. I think IIS is really... Yeah, already you have kind of secret. The ICMP ID is used as secret. So each packet I send, each ICMP packet I send are not opening the backdoor. So maybe I can...
Yeah, exactly. That's your sort of authentication which you have. But you could basically use the same initialization to provide a simple information for it as well, which would make fingerprinting it with an IDS pretty much confusing. So
sure, but yeah, when you follow the we will just see later. When you follow the syscall proxying work, you don't have any real pattern. That's always changing because of the stack, and you don't have really. That's not really easy to make a pattern matching on it. You can do a pattern matching on the shellcode for sure. So maybe I have to write more on the shellcode, but I have to keep it teeny. That's why I didn't integrate it. Oh, just you see the normal ICMP are not opening the backdoor. So yeah, the key is in the IP ID, ICMP IP ID. So, but yeah, for sure, we can work around and we can integrate stuff in the parasite. That's why really I wanted to rewrite it in C code.
How do you realize the chaining of several proxies? How does the proxy know that if the syscall receives this address to itself or it will be passed?
The protocol is really basic. You pack your stack, you send a first packet with the size of the stack you will send to the shellcode. You send the stack packed, and after it reply you with the same size as your stack, just copying the stack and give it to you after. So nothing really complicated. I mean, this technique are already